Theorem 9.2 is the converse of the Pythagorean theorem, which basically states this. You have a triangle, and let's just say you want to determine if it's a right triangle. So if a squared plus b squared equals c squared, a and b have to be the two shorter sides. The hypotenuse would always be the longest side. So if the sum of the squares of the two shorter sides of a triangle is equal to the third side, the longest side squared, then the triangle is a right triangle. That's the converse of the Pythagorean theorem. There's the converse of the Pythagorean theorem written out, and you would want to use the converse of the Pythagorean theorem to determine if a triangle is a right triangle. We'll go through some examples after we go over the last theorem. We saw to the converse of the Pythagorean theorem that we could determine if a triangle is a right triangle. So if c squared is equal to a squared plus b squared, then the triangle is a right triangle. Whether you use the converse of the Pythagorean theorem or the Pythagorean inequalities theorem, for the Pythagorean inequalities theorem, if c squared doesn't equal a squared plus b squared, you could still determine the type of triangle it is by its angles. But a couple of things that you need to keep in mind is you determine what type of triangle it is by the angles for the Pythagorean inequalities theorem. Another is that a and b are the shorter sides, and then that means c is the longest side. But we're always comparing c to a squared plus b squared. Sorry, c squared to a squared plus b squared. If they're equal, then it's a right triangle. But the Pythagorean inequalities theorem states if c squared is greater than a squared plus b squared. Doesn't matter how much greater. If it's just greater than a squared plus b squared, then what you end up with is an obtuse triangle. Triangle ABC is obtuse. So one of three things could happen. Either c squared is equal to a squared plus b squared, then it's a right triangle. If c squared is greater than or more than a squared plus b squared, it's an obtuse triangle. Or the third possibility would be if c squared is less than a squared plus b squared. Can you figure out what type of triangle that would be? If you said it's an acute triangle, that would be correct. That's the Pythagorean inequalities theorem. When you're setting that up, though, just make sure that you're making C the longest side of the triangle.